In this lesson we're going to be looking at what is known as the stopping distance. And so the stopping distance is the distance required for a driver to stop their car in the face, for example, of some type of accident occurring. Okay, so this stopping distance is divided into two parts. Okay, we've got what is known as the thinking distance, and we've got what is known as the braking distance. Okay, so we've got to take both of those into account when we're working out the stopping distance for a car travelling at a certain speed. In this lesson we're going to look at the braking distance first, and in the next lesson we'll look at the thinking distance. Okay, so briefly, what do the braking and thinking distances depend on? Okay, so the braking distance depends upon physical factors related to the car itself, such as the speed that it's travelling at, its mass, the quality of its brakes, and the condition of its tyres, for example. We'll look at all of these in a minute. Okay, but there are other physical factors apart from the car, such as the road surface, the quality of the road surface, and the weather conditions. So these affect the braking distance, whereas the thinking distance really is dependent upon the driver. Okay, so in this lesson we're going to look at the braking distance. So just to help you understand this a little bit better, we're going to take the red distances on their own, alright, and we're going to think about the physics of this. What actually affects the braking distance for each given speed? How can we work that out? Well, what actually happens when a car brakes? First of all, the car has kinetic energy, and that kinetic energy, as you know, is equal to half mv squared. Now, in order for the car to stop, what it's got to do is it's got to get rid of that kinetic energy. If it doesn't get rid of that kinetic energy, it doesn't stop. It's as simple as that. So how does it do that? Well, it does that by applying its brakes, unless it's got some type of parachute which you can release at the back end of the car, which it won't have. It depends upon its brakes. Okay, so what do its brakes do? Well, brake pads push against brake discs inside the wheel, which cause this kinetic energy to be converted to heat. That's what happens when a car brakes. So kinetic energy is converted to heat energy. So we can say that what the brakes are doing is that they are applying a braking force. We call that braking force F, and they will apply that braking force over some distance d, which is the braking distance, okay, d. So what we're saying is the brakes are doing work to change that kinetic energy into heat energy. Okay, and you remember that the formula for work is F, that's the braking force applied, multiplied by d, that's the distance over which the brakes are applied, which is the stopping distance, and that must be equal to the kinetic energy of the car that we want to transfer into heat. So that's equal to half mv squared. Okay, so by looking at this equation we can understand a bit more about what we mean by the braking distance. So what we're saying is that this is the work done by the brakes in order to stop the car, okay, in order to transfer this amount of kinetic energy into heat energy. In other words, in order to lose or get rid of this amount of kinetic energy. So we can just rearrange this equation a little bit, and we can write d as the kinetic energy of the car divided by the force applied by the brakes. And so just by inspecting this equation we can understand what affects this braking distance. So the first important factor is the speed of the car, or the velocity of the car, but the dependency is on v squared, not on v. So your speed is very important when calculating the braking distance. You can see that because of this quadratic relationship, you'll notice here, and this is why I separated the red from the blue earlier, you can see here that there is a quadratic relationship between speed and braking distance. This has a curved quadratic shape, this graph. So you'll notice that if you're travelling at 20 miles per hour, the braking distance is 6 meters, but if you double your speed to 40 miles per hour, the braking distance increases by 4 times. So it's a square relationship. Or if you're travelling at 30 miles per hour, you're 14, then you double that to 60, then your braking distance is now 56 meters. That's 4 times greater. So it depends on v squared. Likewise, you'll notice that the braking distance depends on the mass of the car. So if you're driving, for example, on your own, then the braking distance isn't the same as if you've got a car full of people and you're going on a holiday with a whole load of luggage on top of the car. Okay, so you increase the mass, then you will increase the braking distance. This time it's a direct proportionality. So if I double the mass of the car, then I double the braking distance. So we'll put mass of car, and clearly the other important factor in this equation is the braking force F, and that braking force F depends upon the quality of the brakes. So if you've got very poor brakes, well, you shouldn't really be driving the car, but if you do have very poor brakes, then the maximum braking force supplied by that car will be lower than it should be, and that means that your braking distance will have to be a lot greater. Okay, because this is an inverse relationship. Okay, so the braking distance is inversely proportional to the braking force supplied by the brakes. So the quality of the brakes is important. Now the fourth factor associated with the car is the quality of the tyres. So your brakes can be the best brakes in the world, but if you've got very poor tyres, if the tread on the tyres is very worn down, then when you apply the brakes, the car could skid on the road surface, which would again increase your braking distance. So the quality of the tyres, I just write tyres down there. That's fairly obvious that we want good tread on our tyres in order to have a reduced braking distance. And then there are external physical factors which also affect your ability to brake, which will be the condition of the road surface. Okay, a good quality road will provide good grip for the tyres. So you may have the best tyres in the world, the best brakes in the world, but if the road surface is very poor quality, then that will reduce the friction between the tyres and the surface, and so that will increase the braking distance. Okay, so the road surface is important, and then finally it will be the weather conditions. So a wet road surface will provide less grip for the tyres than a dry road surface, for example, and so that too will increase the braking distance. Okay, so those are the factors which affect the braking distance. And in the next lesson, what we'll look at is the factors that affect the thinking distance.